Hi, today we continue to dive into the topic of using generative equations in top context of Touchdesigner and see how we can play with strange attractors. For example, I chose this little cute one, Thomas attractor. You could find this one on Wikipedia, but also these techniques could be applied to any attractor you would like to build in here. Let's start from scratch as usual. First of all, we have here this set of equations, three equations, and we need to build them. Let's set a point cloud. It doesn't actually matter which one you would like to use here. For example, it could be sphere. And let's set resolution of this one. Next, I would like to split coordinates of this texture into three. Using just simple component for this one. It's very simple. I used this in previous tutorial. It just splitted all channels in three ones. Here we need a feedback because Strange Attractor is a feedback system. These equations are pretty simple. They contain only one constant p. Let's set it. And it should be 32 mono. Next, let's actually build all equations using functions. Here we need sine and angle units radians. And we need also sine of z-axis and x-axis. What we need to do next is multiply our construct by x, y, and z. Next step is to subtract each multiply constant but from its own sign. For example, here sine of y minus b multiplied by x. Here sine of z subtract b multiplied by y. And sine of x minus b multiplied by z. Here we need a reorder. And 32 RGBA. And here we could see a DT, and we can use it as a common multiplier for each equation. So we could just build a math here and multiply by a certain value here. We could even wrote it here. Next, we need to add it to feedback here. Now let's build a simple instancing system. And as we set all equations here, we could start to play with this system. First of all, we need to find a nice constant value, and I found that this one works really well with b between 0.01 although like I think we could slow it down. Yes, this is very like nice result from scratch, I think. And we could see this is totally 3D. And between 0.01 and 0.1. Actually, I think something is wrong here. 1 second. I think this is still nice. Let's just yeah, I made a mistake here. Here yeah, here is should be by. Yeah, sorry for this one, but this is actually why I love to work with any equations in top context, because it's very simple to build this one in GLSL node. I think it's less time consuming, but here are like in this system there are many ways how we can play with it. So for example, it's very easy to like we could change this constant and it contains only one value across whole grid, but we like very easily could implement noise here, and now it contains many values, many different values, and we could adjust it easily. And also we could base this noise not using this feedback system. And get some nice result from here. You could also animate this one. Let's implement cubes here instead of points. Here, let's use phone here. And also let's rotate each cube a little. Also, and now we could play with any node we have here. We could combine different nodes, and now I want to show several ways how we could play with this nice attractor. It's already very uh, beautiful, but it's pretty simple generative system. I mean, it's a common classic look of this attractor, and Touch Designer provides us a lot of ways how we could change it. For example, I've found recently that it's very nice to use displace node after our feedback loop and paste this one on the initial input. It gives us very nice connected look of this one. You could also combine these two outputs between using different operations. Also, you could increase the number of points here. We just leave it like that to be sure that any computer could reproduce this system. And changing constant will also change the look of this one. Next, you could also, as we did in previous tutorials, we could rotate the whole system a little each step of the feedback loop. And it's pretty fast, and you could see how it changes across the time. And it's also pretty easily to do with GLSL top, but now here you could also rotate each of the component and see how each axis affect the behavior of the whole system. For example, let's also nice way to play with it is try to find different combinations between these components. For example, let's combine these y and z coordinates here. And it could provide very interesting and unpredictable systems. And actually, like, I don't really know, but it seems to me like some combinations of them could be new attractors. here we could use add and also speed up our system a little. And you could combine it with any modifications here. Like now we could see how rotation could change the whole system. And not only rotation, but any other modifications too. Like also you could play with pivot. It's very powerful parameter for the whole system. And also you certainly could combine it with noise here. Next, I just recently found, and this is very nice, I think, that you could get a very interesting look using limit node here. We could clamp all values between very small numbers and get a very interesting system behavior, because now it looks like 3D pixelated, because we restrict the movement of each particle at each cycle of the feedback loop. Let's speed up it a little. And I think this would be very nice to see how this exact technique could be applied to different attractors. And also, very nice thing that we can do actually is the combination of the one attractor or different attractors combined in one system. For example, let's collapse it. And duplicate system. And here we could use different operators to get a new look. For example, something like this, or we could, let's set here less speed, and here we will leave limit and combine them using brightest. So we could get something between, like, blend between these two systems. Which could be pretty difficult to get using other ways. I think this is it. I hope you like it. Thank you so much for your support. I'm eager to see your results, and see you next time.